I'm going to turn all the planets in our galaxy that could have alien life into marbles and put them in here, the Colosseum in Rome, to give an idea of just how many planets could be like Earth, that could have alien life. Then I'm going to show you how one of these blue marbles, a planet that we found recently, might actually have alien life on it, how we found it, how we might confirm it, and where else we might find life. We live in a pretty flat galaxy called the Milky Way. If I scale it to 100 meters across, covering the Colosseum's arena where the gladiators fought, it would only be about 1 meter thick where we are. There are at least 100 billion stars in here. If I make them all bright enough to see, it just looks like a cloud. So let's simplify the galaxy. Let's make it a flat map and focus on the exciting part, the blue marbles. Every blue marble I put in here represents a habitable planet. These are small rocky planets like Earth that are the right distance from their star to be the right temperature for liquid water, the important thing life on Earth needs. Here's blue marble number 1, Earth. The only planet in our solar system in the habitable zone. Obviously, it's not to scale here. We're just making these planets a size we can see, like a pin on a map. Exoplanets, that's planets beyond our solar system, are incredibly difficult to find. Imagine trying to spot a speck of dust in the air at night near a candle 20 miles away. If I made this video in 2010, I could show you all the exoplanets we'd found, around 400. You'll notice they're close to Earth and big. That's all we could detect. I haven't made them marbles as they're big gas giants like Jupiter, not small rocky ones like Earth. So none of these were candidates for being habitable exoplanets. They were just big enough to wobble the star they orbited. That's how we found them. In terms of blue marbles, 15 years ago, we still only knew of one, Earth. Then everything changed. The Kepler Space Telescope launched. It didn't look for wobbling stars, it looked for blinking stars. More accurately, it looked for regular dips in brightness caused by planets passing in front of these stars. This is called the transit method. It's like when a bird flies in front of the sun, momentarily blocking it. But it's a terrible way to find planets, isn't it? For the same reason, we hardly ever notice a bird flying in front of the sun. It's much more likely to not fly in front of the sun, just like it's much more likely for a planet's orbit to not line up exactly with us. If you were at a random point in the galaxy looking at the sun, the odds that Earth would line up with it and dim it every 365 days would be less than 1%, and it would only dim the sun by 0.008%. You'd need to watch it for more than 2 years to make sure it was a planet that was regularly orbiting. To detect Neptune, a planet that takes 170 years to go around the sun, you'd need to observe the sun for more than 340 years to confirm Neptune was there. So again, this is a terrible way to find exoplanets. It's a miracle Kepler found any, and yet in a tiny section of the galaxy, it found thousands of them. In fact, it found something totally unexpected. Kepler found out there are more planets than stars out there. We used to think exoplanets might be quite rare and the solar system really unusual. Kepler took us from, we're not sure if there are many planets out there, to, oh, there are hundreds of billions of planets per galaxy. But that wasn't the most exciting part. We learned that almost 1 in 2 stars near us has a rocky exoplanet in the habitable zone, a potential blue marble, around almost 1 in 2 stars. Personally, that's completely changed how I look at the night sky. Kepler discovered there are around 40 billion rocky exoplanets in the habitable zone in our galaxy alone. 40 billion planets with the potential for life. And that's why we're here. Big numbers don't mean much to me. So let's actually see how many potential Earths there might be in just our galaxy. Just a reminder here that the Colosseum represents just one galaxy, and there are lots of galaxies out there. It's a little difficult to process just how many potential Earths we have filling up this space. I'm showing it here in its original full size, but despite being almost 2,000 years old, the Colosseum is still the largest amphitheatre in the world. It's twice the volume of Madison Square Gardens, and we believe it could seat up to 80,000 people. That's similar to a large football stadium like Wembley Stadium in the UK or the Rose Bowl in the US. And yet, the marbles keep filling it up. I've added the Statue of Liberty from the feet up to help give an extra sense of scale. Now, if you hadn't guessed already, you can indeed fill the Colosseum with blue marbles representing potential Earths in our galaxy. Each one of these is a rocky planet in the habitable zone. This is what 40 billion looks like, and it's pretty overwhelming for the ramifications for whether there's alien life out there. But let's take this a step further. Let's shrink down the Colosseum of planets to the size of a peppercorn. It now fits snugly inside a single piece of cereal. In my last video, I turned all the galaxies in the observable universe into pieces of cereal and poured them into a swimming pool. Each of these galaxies, each piece of cereal, contains its own micro-Colosseum, packed with billions of potential Earth-like planets. And I can now complete the shot I started in my last video. We live on this rocky planet in the habitable zone. Earth, our blue marble, among the billions of other marbles in our galaxy. Our arena of wonder, the Milky Way. Just one piece of cereal in an observable universe with enough pieces of cereal or galaxies to fill up 355 standard size swimming pools. I'm never going to be able to fully grasp this kind of scale. I don't think anyone can, but I think this is the closest I can get to explaining these numbers in a way that makes sense to me and is something I can remember. This perspective can feel overwhelming, but the more I think about it, the more it actually fills me with awe and hope. Even if humans are around in 1 million years, and even if many of these galaxies are unreachable to us, we still couldn't put a dent in visiting all of these worlds. If we wanted to, our future will always be full of adventure and exploration out in space. And of course, there could be so much alien life out there for us to find. But this isn't the whole picture, and I might just surprise you with why it's not. Firstly, we need to be sensible and look at counter-arguments to these numbers, filters that reduce these opportunities. Earth has a strong magnetosphere, protecting us from solar storms and keeping our atmosphere intact. Without it, life like ours wouldn't exist. This is what we think happened to Mars. It used to have an atmosphere and rivers of water, but because it only had a weak magnetosphere that eventually stopped, the sun's solar storms stripped its atmosphere away. How many of these marbles have the same protection Earth does? Probably quite a few, actually. Magnetospheres aren't unusual in our own solar system. Many of our planets have them, though it's mostly the larger ones. There are other filters we can apply to these numbers. 70% of these marbles orbit closely to cooler, more erratic stars than our sun, called red dwarfs. Volcanoes, atmospheres, plate tectonics, chemical compositions, there are lots of variables that can affect the probability of life like ours thriving. The more we can understand about exoplanets and the planets in our solar system, the more we can adjust these numbers down. But that's what we hear about most, isn't it? I think we have a slight bias that we feel these numbers should be smaller. We hear about all the variables that might make life less likely. Something that isn't discussed as much is adjusting these numbers up. What if this pile of worlds that might have alien life is too small? It makes sense that we look for rocky planets in the habitable zone because that's, like Earth, we have lots of life. We have liquid water, pretty much the only thing life needs. But I mentioned Mars a second ago having water, didn't I? We think it had rivers of water for more than 1 billion years. Mars has never been in the habitable zone, so wouldn't pass the checklist to get into this pile. It was only warm enough because of a thick atmosphere and lots of volcanic activity. So we need to take planets away from this pile because they have the wrong atmosphere and the wrong amount of volcanic activity. But then we also have to add planets to this pile because they have the right atmosphere and the right amount of volcanic activity, even if they're not in the habitable zone. Europa, Jupiter's ice moon, we think has more liquid water than all the oceans of Earth put together. It should be much too cold, but it's heated by something called tidal forces. This is when Jupiter's gravity squashes and stretches the moon as it comes closer and further away, like squeezing something in your hand can warm it up. Other moons that might have liquid water include Enceladus, Ganymede, Titan, Callisto, Triton, Mimas, and even dwarf planets like Ceres and Pluto. Mars may still have some underground water too. That's 10 possible locations for liquid water in our solar system, and 7 of those are moons. Each has its own challenges. For instance, Jupiter's strong magnetosphere can reach out and protect Europa from the solar winds of the Sun, but the same magnetosphere powers even more harmful radiation of its own that might get through its icy shell. Each moon is quite different, but that's perfect. Variety means opportunity, and none of these 10 worlds are in the habitable zone. None of them would make it into this pile of marbles. It feels like for every good argument to make this pile smaller, there's a good argument to make it bigger. So, if there is life out there, we might be more likely to find it on a moon, not a planet. And the numbers are even more astonishing for moons. There are hundreds of moons in our solar system, and exomoons probably greatly outnumber exoplanets too. Because of tidal heating, none of them need to be in the habitable zone to have liquid water. So while there may be 40 billion rocky planets of opportunity for water and life in our galaxy, there could be hundreds of billions of moons of opportunity to add to this. There's also another problem with trying to make these numbers smaller. These numbers assume something that makes sense, but isn't very logical. They assume alien life is just like Earth life. We have to do that as life on Earth is the only life we know of. It's the only data we have. But alien life could be silicon, not carbon-based, or exist in an environment we wouldn't expect. It will have had a completely different history of natural selection in a very different environment. It might not need water. In 2020, phosphine was possibly detected in Venus's atmosphere, something that probably can't happen naturally. On Earth, it's created by large amounts of microbial life. The surface of Venus is ridiculously hot, but high up in the atmosphere, the temperature and pressure are actually similar to Earth. But if there is alien life in Venus's atmosphere, it would have to thrive on sulfuric acid instead of water. But that might actually be possible. NASA hopes to send the Da Vinci probe to Venus's atmosphere in a few years to confirm whether there is alien life there. The mission has been delayed due to budget constraints and is even in jeopardy of being cancelled. Life on Earth, life that we understand really well, has constantly surprised us over the years with its ability to exist in places we didn't think it could. I don't like to use the word definitely much when talking about science, but this I think is one of those times I can. Alien life would definitely be different to ours, in where it can survive or thrive, and that only greatly increases the number of planets or moons to add to this pile. Which brings us to the very obvious question. Even if this pile is smaller or bigger, with so many potential worlds, where is all this alien life? Why haven't we seen it, found it, photographed it? Why haven't the advanced ones said hello, invited us over for a cup of tea? This is such an important question, so there are so many ideas and theories about why we haven't found it. The Drake equation, the Fermi paradox, the Great Filter, the rare earth hypothesis, the zoo hypothesis. There are many more. Lots of interesting ideas, lots of complicated words. It's hard not to guess when the question is so important to us. But I personally think the reality is actually more common sense and doesn't really need the word hypothesis after it. The reason I think we haven't found any alien life yet is we haven't had the power to find it until now. This is best explained with a quick and simple example. We have these huge radio telescopes, right? James Bond had a fight on one of them. We have optical ones too, with mirrors, even some in space. We can see things towards the edge of the observable universe, right? That's all correct. So let's make an imaginary twin Earth, and we won't put it in some distant location away. We will put it the closest possible distance to us, and let's train every powerful telescope we have on it. This is the ludicrously best possible case scenario. Our twin Earth would be going around the closest star to us, Proxima Centauri, a little over 4 light years away. On my map back at the start, Proxima Centauri would be 4 millimeters away from Earth. Because our marbles aren't to scale, they'd literally be fused together. They're so close. Can you even tell this is 2 planets? What level of detail image can we take of this twin Earth? Here. How clearly can we hear their radio transmissions? Can we watch their alien TV broadcast over radio waves? The astonishing answer is we would detect absolutely nothing. Unless they were deliberately trying to send a signal directly at us, we would detect nothing from the closest possible distance to us. Isn't that unexpectedly ridiculous? Our telescopes don't have the power to detect our own random radio signals or take a picture of us if we were the closest possible distance to us. We have all these theories about why we can't see alien life, but we're saying these things while we sit here with our eyes shut. But the great news is we're just starting to squint a little. One of the craziest things I discovered when researching this video is that our imaginary twin Earth going around Proxima Centauri isn't even imaginary. In 2016, we discovered a rocky planet in the habitable zone, very similar in size to Earth, going around Proxima Centauri. We have a twin Earth, the closest possible distance to us. It's called Proxima b. We don't even know if it has an atmosphere yet. It's unlikely to be similar to Earth though, because it orbits closely to its red dwarf star, which might make it difficult for life like ours to exist there. We have so much incredible technology, and science is so good at overcoming problems. So why are we so blind to such an important question? There are different ways to answer that, but I feel like the most accurate answer is slightly awkward to talk about. We haven't been able to look properly for alien life yet, not because of technical limitations, but because, as a society, we spend more money on pet costumes every year than the entire 10-year budget of the Kepler mission. That, fundamentally changed our understanding of the universe. I'm not blaming pet costumes. How could I? I'm just saying science, even space science, is underfunded. NASA and other space agencies work wonders with limited funding, despite repeated studies showing that for every $1 spent on NASA, the US economy gains 3. NASA's exciting Dragonfly mission to send a drone to Saturn's moon Titan to look for life had multiple delays over the last few years, trying to get funding. If it was funded when it was first confirmed, it would be halfway there now. Currently, it might launch in 2028, arriving in 2034, or it might not launch at all. As of May 2025, NASA's budget is in danger of being drastically cut, something that would cancel almost every mission involving searching for life. NASA and the Planetary Society have been pushing for a mission to Europa for almost 30 years now, but the Europa Clipper was only launched last year in 2024. Science can work wonders on a shoestring budget, so we assume it always can. But the biggest problems require a bit more string. Perhaps the best example of not using much string is SETI, the Search for Extraterrestrial Intelligence. They use radio telescopes to listen for signals from advanced civilizations. It's one of the easiest, cheapest ways to find alien life. That might sound confusing because I said we couldn't detect life on nearby planets, but the difference is they're listening for deliberate, powerful communications. They haven't found anything yet, apart from one brief, unexplained signal in 1977, but an absence of evidence is an evidence of absence. This is one of the places many people have expected or hoped to find alien life quickly. But the thing is, we know of only one way a species can become intelligent: self-replication, variation, and a hostile environment. That means any advanced alien species that went through that would almost certainly understand survival and self-preservation. Even if they've become AI or have evolved beyond crude emotions, they'd still recognize that others might not have. This is where it gets a bit dark. If an advanced civilization had technology to travel through space faster than us, it could probably direct an asteroid like a bullet at a planet hundreds of light years away. You might have read or seen that in science fiction, but it's totally reasonable. On a galactic scale, we all kind of live in glass houses with plenty of stones lying around. I think it's unlikely a species would do that, but that vulnerability shouldn't escape any intelligent species. This idea is known as the dark forest hypothesis. Civilizations stay quiet to avoid drawing attention. We call it a hypothesis, but some ideas like checking the strength of ice on a frozen lake before jumping on it are just common sense. And the smarter you are, the more likely you are to have common sense. So any civilization smart enough to send a deliberate signal should also be smart enough to know not to. The only flaw in that argument is that we've done it. We've sent out about 5 deliberate signals. But if we stop now, and I hope we do, those signals are just tiny, weak blips in cosmic time. Even if a million alien civilizations exist in our galaxy, the odds of us listening at the exact moment one makes an early mistake and says hello are very small. But that's why SETI must keep listening, because we just don't know how much advanced life there is, and we could get lucky. The longer we listen, the luckier we might be. But while we listen, we also need to look, and that's the hard part, which brings me to alien life that we might have already found. In 2015, Kepler discovered the rocky exoplanet K2-18b in the habitable zone, using the transit method I talked about earlier, where a planet dims a star as it passes in front of it. This method might be rubbish at finding exoplanets, but it has an incredible side benefit. Imagine someone 2 miles away. On my camera, they're too small to see, smaller than 1 pixel. But if they turn on a bright flashlight, I can see the light. It has the power to light up a pixel of the camera, even if it's smaller than a pixel. Now, if they put a gummy bear in front of the light, I can tell it's red, even though it's way smaller than a pixel. This is exactly what we do with stars and planets. Even though distant stars are just 1 pixel on our telescopes, When a planet passes in front of its star, it's backlit by the star, and the colour of the star will change as some of the light travels through the atmosphere of the planet, just like the red gummy bear. But instead of just looking at its colour, we can look at the full spectrum, and we can see dips in the frequencies where specific atoms and molecules absorb that starlight. So we can actually detect atoms in the atmosphere of K2-18b, a planet we can't directly see, from 120 light years away. This is such a good example of the power and wonder of science to do the seemingly impossible. And this method is one of our strongest ways of finding alien life. Hubble, and now the James Webb Space Telescope, can see the planet K2-18b probably has water, hydrogen, helium, methane, carbon dioxide, no ammonia, and possibly dimethyl sulfide, or DMS. We only know of one way that could be produced: life. On Earth, DMS is only produced by life, by animals, plants, and bacteria, but most of it by plankton in the ocean. And K2-18b has all the indications and chemistry of being something called a Hycean world, a water world. It really could have a lot of simple alien life on it. To confirm that, we need more data, more observations every 33 days when the planet transits. NASA will remain cautious, I'm sure. Extraordinary claims require extraordinary evidence, and the DMS signature in that signal is weak. It's at the limits of the power of JWST. So I need to quickly interrupt my own video here, because the day after I filmed this video, there was an announcement from a research team looking at the K2-18b data, and they said they were 99.7% sure that K2-18b has DMS. So very strong evidence for alien life. But then 4 weeks later, there was criticism of that from a different team looking at the same data and more, and they felt K2-18b's DMS signal wasn't clear enough and too close to methane to be sure it was there. So, who's right? It's probably best to err on the side of caution for now. The second team believe we need to look at data from 26 transits to have a strong idea either way. So we need about 5 more years of data. So the situation now is we do have tantalizing evidence that this could be alien life. But again, it's at the limits of JWST. But in about 5 years, the ELT, a telescope I'll mention in a second, will be complete. So data from there and more transits from JWST should give us a more definitive answer as to whether there is good evidence for alien life on K2-18b. And just to clarify, K2-18b is one of 3 rocky planets in the habitable zone that we have looked at the atmosphere of. We've looked at just 3 blue marbles among the 40 billion, and one of them is already very exciting. But if we start detecting similar molecules on other planets with JWST and future exciting telescopes like the ELT here, the remarkably named Extremely Large Telescope, we might find stronger signals. We've only just begun analysing exoplanet atmospheres. That is us starting to open our eyes. And as we gather more data, we may uncover surprises about the diversity of worlds around us. If we can't gather enough pieces of the puzzle from there or from the ELT, the HWO, the Habitable Worlds Observatory, the successor to JWST, is hoping to launch in the 2040s. It will be the first telescope primarily built to search for life on other planets. It is an incredibly important telescope. Building bigger telescopes and arrays and missions to moons with water in our solar system seems inevitable, but it's not. It requires money, and that means it requires support and enthusiasm for space and science from the general public. The more we support science, the sooner we will answer the question of whether we're alone. Which takes me to a fact I'm really proud of. This video was sponsored by the Planetary Society, a non-profit founded by the wonderful Carl Sagan. Their mission is to involve their members in the search for life beyond Earth. advancing planetary exploration, and helping to defend the planet from asteroids. They genuinely do those things. For instance, they've helped support SETI for 45 years now, and were the driving force behind the Europa Clipper mission happening. In my opinion, the most exciting search for life mission we've ever undertaken. It will arrive at Europa in 2030. They have a worldwide community of 2 million space enthusiasts and are currently fighting to stop NASA's budget being drastically cut. If you feel we need much more space funding, not much less, then you share their goals. If you're passionate about our search for alien life and humanity's future in space, you can join them and become a member today at planetary.org/spaceman. There's also a link at the top of my description below the video. I'm a member and I'm very happy to be. Nobody knows how much alien life there is out there. We need more data to understand whether this pile is smaller or even bigger. But hopefully this video has helped improve whatever your guess is as to whether there is life out there. All I know is the last 30 years of science has built up this unexpected ocean of statistical opportunity for life that seems too big to evaporate away completely. When trying to guess if there's alien life out there, I try not to let my feelings of hope cloud my judgment, but I think that hope is justified. For me, there is nothing more exciting in the universe right now than the idea of sending a probe to land on Europa or Enceladus. I worked out that this is what the genuine view would be like from Europa. A future mission involves what NASA calls a cryobot, a radioactive robot creating its own heat that would melt its way through the icy crust, taking perhaps 2 years to melt through 20 kilometers of ice, slowly descending into this frozen black abyss until at last it hits water. Its camera and light flicker on, sending video to the surface, revealing the secrets of an alien ocean bigger than anything on Earth. What would we see? As much as it sounds like it, this is not science fiction. This is something that we will probably do. The mission would cost around 1% of the cost of landing people on Mars and bringing them back safely. Getting people on Mars is profound and inspiring, and I'm all for it. But all of these missions, Dragonfly, Da Vinci, this ridiculous cryobot mission to Europa or Enceladus, they all cost 1% of a Mars mission or less. HWO costs about 2%. There are even a few people out there who could personally fund these missions. Imagine if the HWO was cancelled, but then a single person funded it and it found evidence of alien life. Imagine the person that helped change humanity forever. What a legacy that would be. Maybe Jeff Bezos will see this video one day and feel the same. As for advanced alien civilizations, they're likely far rarer if they exist. It seems likely that most life would be like bacteria, plants, or maybe jellyfish. On Earth, it took 4.5 billion years to evolve an intelligence like ours, so the vast majority of life even here has been very simple. We'd expect to see the same out there. Advanced alien life is going to be harder to find, I think. Not necessarily because it's not there, it just makes sense to me that if it is out there, it would be a cautious explorer. There are so many creatures on Earth that seem alien to us. Can you imagine the variety and strangeness of what might be out there for us to find, evolving in incredibly weird environments? It's no wonder we love sci-fi so much. It's often bizarre fantasy that's entirely possible. I might disappoint some people here with my pragmatic guess, but I don't think any advanced life has visited us. Or if they have, we'd never know. I think we'll probably earn our answer to perhaps the biggest question ever. Are we alone? We have forged our ability to start opening our eyes to the galaxy, and we will start to see in an ever-increasing bubble that will soon encompass our neighborhood of planets and stars. To paraphrase some of JFK when he was talking about going to the moon, we choose to explore our universe and understand the worlds out there, not because it's easy, but because it's hard. Thank you for watching my video on the search for alien life. I've actually got an extended version of this video on my Epic Spaceman Patreon channel that's about 10 minutes longer, where I talk more about my personal opinions on what's out there and go into more detail about the possibilities for advanced alien life. Do please check it out if you'd like to see more. And of course, there's more behind the scenes videos there, access to the videos without adverts, plus you can feature in future videos too as an astronaut, like my wonderful supporters here. I spent about 4 months writing and rewriting the script for this, and about 2 months making it. It's been one of the hardest ones I've made, as I wanted to do the topic justice. If you've been enjoying my videos, sorry it took me so long to make this one, but I hope you enjoyed it. People do keep asking, so just to clarify, I didn't use any generative AI to make this video. AI can make great tools, but I'm not a fan of fake humans or taking creativity away from real ones. I'm the real person behind this channel and the person in the suit. I make these videos on my own in wonderful free 3D software called Blender. Otherwise, thank you for all the incredibly kind comments on my channel. I'm always overwhelmed by the support and it motivates me so much. I try to reply to as many comments as I can, and of course do feel free to like, subscribe, ring the bell, etc. if you enjoyed it. This was my 9th main video for my channel and I can't wait to finish my 10th. I've already started making it, so it will be a shorter wait than usual. I hope to see you again soon for another Epic Spaceman video. Cheers.